Okay, hey class, how you doing? I am glad to see you guys again. Hopefully you enjoyed our interaction last week in our discussion board regarding minerals and learned a little bit about some of the uses of different minerals. That was the point of the discussion page, is to be able to know that if it's not grown its mind, right? We use our mineral resources for everything around us, from the iron oxide, from hematite, which we use in blush of cosmetics, or talc, which we also use in cosmetics. I know you guys like to smear rocks on your face, right, you gals out there. But anyways, the point comes, it doesn't really matter what the use is. Everything we have around us comes from the earth in some ways. And so that's why we're emphasizing that part of minerals and in our sedimentary rock section or our other rock sections about what we use this material for, right? So this week we're going to be talking about sedimentary processes and resources. And so we looked at last week minerals and then started talking about rocks a little bit. And so what we're going to do is we're going to go through the individual parts of the rock cycle to be able to understand sedimentary rocks first. Then we'll talk about igneous rocks and then metamorphic rocks later on. So this week, by the way, this is called the Wave. It's in southern Utah. It's basically a bunch of sand dunes, of ancient sand dunes that were in that region during the time of the dinosaurs. And it's now been hardened, turned into what we call a sandstone. Okay, so it used to be a sand dune, now it's a sandstone, where it's been lithified or made into a rock over time. So like we said before, we're going to be talking about this portion of the periodic table, the sedimentary rock cycle, cycle as a whole, where we're going to talk about first weathering, the breakdown of rocks, really, then the transportation of that material, or what we call sediment, the deposition of that sediment, then we're going to go into talking about sediments, the lithification and compaction of those sediments, and then to sedimentary rocks. Okay, so sedimentary rocks are very important because it helps us understand the past. Sedimentary rocks are used to look at clues in the past rock record, right? So we can know if they were deposited on the continents or on floodplains, sand dunes, at the water's edge, in the sea, based off of characteristics within the rocks themselves. And they also preserve evidence of fossils, so they help us to understand our fossil record. Okay, and we do that by giving us clues from what we call its depositional environment. This goes back to a concept that we call that was first. What's happened in the past basically happens in the future as well, and so streams deposited or ran in the past, and they do to date as well. So the features that you'll see inside of the bottom of a stream probably were also seen in other rocks around the world. And so we'll talk more about that in the past. So it's this principle of what we call the present is the key to the past. Okay, and so we're going to look at what depositional environments are, which is basically the environments in which these rocks or sediments were deposited in. So here's some examples of some of the sedimentary rocks. There's 6 different rocks here, and in class what I would usually do at this time frame is I would give samples of some of these types of rocks to my students, and then we would try to figure out, well, how did this rock get deposited, what kind of rock is it, and so forth. So this rock we have right here is actually a rock that we would find in our neck of the woods. This is actually part of what we call the Middendorf Formation. And it's the rock that if we drilled down below our feet right here, and that material was to be solidified, this is what it would look like. Okay, so there's lots of sand in here, but there's some bigger grains in here as well. And this rock here, and there's even you can see the layering in this rock here as you go across this area here. You can see the different layers here. So this rock was deposited in a big delta as the river would actually come out onto the ocean. It would deposit these sediments out. And you can kind of see that because looking at the different sand, it looks a lot like beach sand in a sense, or something that might come out of a river. You look at the grains, and they tend to be all the same. There's a lot of red hues in this, telling us there's iron in the water as it flows through. And there's lots of different indications in different layers. So here's a coarse layer, then there's a fine layer on the top here. So this gives us a sequence of events that have occurred in the past. So we can look at these clues to be able to understand its past. So this week in your discussion page, you're going to be doing something just like that, where you're going to be looking at some rocks that I give you, some 3D rocks, 3D images of rocks. We do some of those images here in our department. Mostly I do. And then some from other people around the world. But what you're going to basically do is you're going to make some observations. Make some observations regarding those rocks, and then try to determine or classify what kind of sedimentary rock it is, and what that environment was in the past. Now we're going to give you some clues throughout these lectures to be able to help you with that. So it would be beneficial for you to actually go through the lectures prior to doing your page. Okay. So here's some examples of some of these. Here's a rock here. Notice that it's very jagged. They're not very rounded pieces, and so this rock here probably wasn't transported very long. With the grains within it weren't transported very long. It might have been deposited off the side of a cliff where it fell down and those sediments weren't moved. But over time, they were cemented together to form this rock here, which we would call a breccia. This rock here is, if you notice, is a bunch of fossil pieces and also some organisms that we call crinoids, and it would actually react with acids to it, so it would what we call effervesce, so we could know that it's actually made from calcite. Okay, and so we call this a phosphorus limestone. So we can look at that by doing that. You look at this one here, you can see the layers throughout this rock. Those rock layers tell us that the sediments were deposited in some kind of a fluid, most likely water, but can also happen in sand dunes as well. So where the fluid in that one is the air, as the sand is moving through the air, right? So this can tell us that this rock here was probably deposited either in a lake, because it's a fine-grained material that's within it as well, would also give us indications of that, because that sediment would move if it was in a river downstream and wouldn't deposit, but if it slowed down so that sediment could finally fall out of solution, then you would actually have some deposits like this one. Okay, we'd call that either a clay stone or a shale, or even maybe a siltstone. These two here are both examples of sandstones. This one has different features in it. This is cross-bedding, which tells us that it was probably within a sandstone or in a river, as the water usually is deposited in horizontal layers. Well, but sometimes if it was at the edge of a deposit, like at a sand dune, it can deposit on an edge there to form these cross beds associated with it. These here suggest that this was in a river or even in the oceans at some point. So because you can see what we call ripple marks in this. So there's clues in all of the rocks that tell us a little bit about where that material has come from. This one right here is also looks like it's a sandstone. But all the little sediments cemented together to form that rock over time. We'll do this more, but I just wanted to kind of help you understand that these are clues. And in a sense, I call this instead of CSI, which is your crime scene investigation, I call this the GSI, right? Your geological science investigation. And we can learn a lot about the past by looking at these rocks and to be able to understand how they were deposited, how they were moved, where the rocks came from. A lot of material can be inferred by looking at a rock. Okay, and we'll want to look at those clues and use those clues to be able to help us understand the world around us here. Okay, so why else are sedimentary rocks important? Well, this is where we get a lot of our sedimentary resources, our natural resources. So oil, coal, natural gas all come from sedimentary rock deposits. And those are things that we use to burn for fossil fuels, for our energy, every single day. So it's important for us to understand how rocks are deposited so that we can understand these resources. Also, these rocks also store and transmit groundwater. We, in our neck of the woods, actually receive most of our water, our public drinking supply, from groundwater. And it flows kind of like a sponge. That water flows through those rocks and often filters any contaminants from the surface out so that our groundwater can be clean. So that's an important reason sedimentary rocks are important to understand them, I mean. They're also a source of our soils that we grow all of our crops from, right? The broken down rocks within the soil gives us all the nutrients that we need within those crops. And if we continue to farm, for example, farmers often will rotate their crops because the nutrients that the plant extracts from the rocks or the soils will be taken away over time, so they'll put new plants in there to actually replenish the nutrients. And so soil is a really important part of our everyday life because we get a lot of our food from that. They also can help us to understand Earth's history, so we can understand what the fossils were in the past, like dinosaurs and other organisms that lived here in our past, so we can understand that history in the future as well. So they're all really important aspects and things that we need to understand a little bit better. So this is one of my famous flow diagrams or concept maps. I love these things because they help us to understand and summarize how things work. This one's kind of detailed, and I'm going to be referring back to it throughout these lectures. And so this is a good summary slide for you to go back and to study from to be able to understand how these rocks work. So let's start at the beginning here. As any rock at the surface undergoes a type of weathering, and we'll talk about each of these points a little bit later. So my granite, my granite that I have here, could actually be slowly weathered or broken down, and it could be done either chemically or mechanically, physically broken down, like broken down into smaller pieces, or chemically dissolved and broken down. Okay, so let's go the chemical route first. So if you have the chemical route and it actually dissolves there, so you have dissolved ions, and then those can undergo erosion by streams and groundwater, transporting that material away. Usually it's going to end up in the ocean. That's why the ocean is salty, because all that material from the surface, on our surface, is slowly dissolving away, and those salts, or the materials that it dissolves, ultimately goes into the ocean, and therefore it concentrates that water slowly over time. Now, if you have too much concentrated in there, it's going to start to crystallize. So things like salt, halite, will start crystallizing out, or can often be aided by different organisms. Just like we take minerals and stuff from our food to make our teeth or bones or something like that, other organisms like clams and corals take materials out of the water to make their shells, right? Then that material can solidify on the bottom of the ocean through basically chemical oozes at the bottom, or from fossils like these guys, and then dead bodies will float down to the bottom, and then we'll get an accumulation of them there. That's where oil comes from a lot of times, is from the microorganisms that fall to the ground and then get compacted over time. Then they get deposited and then lithify. Lithify means to make a rock, okay, or to harden, and that usually happens by either compaction or cementation. And then you'll get your chemical sedimentary rock. A good example of that might be limestone, like this rock right here. Actually, you can see the different fossils in it. This is an old coral, and it was a chemical sedimentary rock that actually solidified in a shallow sea, right? So that's just an example of one. Now, if we go back the other way, where we have mechanical weathering, where it creates sediments or clasts, clastic materials, clast meaning particle. So particles like sand, gravel, silt, and mud are broken down, creates those sediments, and then undergoes erosion, where it starts getting transported away by either streams, waves, glaciers, gravity, or wind, right? Then they can be deposited, usually because the energy slows down, and therefore something that might be a lot of big particles moving in the water, it slows down, so now the energy doesn't have enough energy to move that bigger stuff, so it drops it and deposits in maybe a river deposit. Then it might get lithified once again by compaction or maybe cementation. As water flows through it, it has chemical ions in it that can slowly concentrate and precipitate in between the rocks to solidify it together. That's how it happened with our sandstone that we showed you earlier, with that sand that was beneath our feet, right? Now that can become what we call a clastic sedimentary, like the ones I just showed you, which was a sandstone. Okay, or maybe like this one right here, we can see all the different rocks within it and gravels within it, which we call conglomerate. We'll get back to some of the details of those. Now, let's say that you had some of these plants actually be your sediment now. Okay, so plants can actually compact together to be deposited maybe in swamps and lithify to make what we call coal. So here's an example of coal that we can burn for our fossil fuels, and this is an example of a sedimentary rock. Mostly from plant material. Okay. Now, other things like So there's lots of different examples of this all around the world. This is just a flow concept map to get you in that pattern to figure out where these things are. Now we'll come back and talk about some of all these details